Welcome to MorpheusChair, the program where you learn how to build robots like these in your comfy chairs. So thanks a lot for the support. We really like your comments and requests, and we hope to give the best programs we can. So without further ado, let's get started. In this program, we are going to make this build. So we're going to add the battery pack. We're going to basically make it autonomous in the way of the build, no cables, not anything. And the most important part is that we're going to install ROS. So with ROS, we're going to be able to publish the camera images into a topic and see it. And we are going to also connect through SSH. So I've divided this program into basically two parts. The build, we install the camera, we install all this rack, and we install it to the robot. And the second part is making the SSH possible, installing ROS, and moving the robot through CommandVal with the keyboard through ROS. Without further ado, to the workbench, to the workbench, to the workbench, to the workbench, to the workbench. Let's go to workbench. Okay, so we're here in this assembly. This is going to be a long one. We're going to do the following. We're going to get the battery pack for the Raspberry Pi mounted here in this plastic support. We're going also to get the Raspberry Pi in its final support. We're going to install also the heat sinks, and also we're going to install the camera. You can see this is the camera that we are going to use. Okay. And finally, we will install again the motor drivers board. Okay. So let's get going. So the first thing that we're going to do is mount the battery to its final support. We just have to put this supports here like this, and then put this screw on. That's it. Yeah, so let's go. Okay, so we have it. Be sure that it's well secure, because we don't want moving parts when we have a mobile robot. It's just that, to protect all the pieces and electronics. So now we're going to place the battery. There we go. And now the screws with the Phillips. That's it. So as you can see, I don't have the other screw, but it's not necessary. Just be sure not to lose yours. And then I've added a small feature, which is this magnetic element, so that I can charge it with a magnetic charger, which is quite neat, because you don't damage the connectors as much of plugging and unplugging all the time. It's really cheap and it's convenient. You just plug it here, that's it. And then you get this dongle for your charger, Raspberry charger, like that. You just have to plug one end here and the other one just connects like that. Yeah. Perfect. Okay, nice. So we have the battery mounted. So let's continue with the next one. So the next part is going to be mounting the Raspberry Pi into its support. So for that, we're going to do the following: the Raspberry Pi into the support. So be sure that these supports are cut custom for this. This is for the SD card, so this goes there. And then be sure to get this right, just because on the other side you have this chip, which has to be cooled, and we'll use some heat sinks for this, so bear that in mind. So let's screw the Raspberry Pi. We're going to use these small screws that we got here. So let's go. As you can see, it's very good tip to just screw the diagonal screws. That way you have it already secured, and don't screw it to the end. That way you can adjust the height. Yeah, and now let's screw the other two. So there we have it. So as you can see, I've screwed with the hand. It's much easier and it's more secure for the components, just because we don't exert as much pressure as with a screwdriver. So I would recommend you to do it with your hands, and then just test that you have, and then test that it doesn't move. Yeah, that's it. Okay, great. So now we're going to install the heat sinks. So you can do it as however you want. This small is just for this chip, and the big one is for the big chip. And then the lower one is also very big, but they give you this one. So there we go. So now we have them installed. And we're going to install the lower one. Yeah, so we have it. Great. So now we're going to install the camera. So the camera. This is the official camera licensed by Raspberry Pi, and it may come without this cable attached, but in this case it came with it. But the procedure is exactly the same as the one I'm going to explain now. So here we have the camera connector. So if you can see here, it reads camera. Let me focus. There you go. So it has some pins here, and you see that the pins are facing that way. So facing the Ethernet connector. That means that when we connect this, the blue part, this one, goes facing the Ethernet port, so that the connectors, which are here, make contact. Okay, so to get it, you just have to open like that. You have to pull, and then connect the camera. Okay, once you feel that it's secure, we have the camera connected. So now the only thing that's missing is installing our driver for the motors. So for that, we are just going to... So we have now our Raspberry Pi with the camera attached. Perfect. So now in the last part, we're going to mount it on top of the robot. So now we're going to marry, let's say, the battery with the Raspberry Pi. So for that, we're going to use these spacers that we have here. So it's one for each side, and then we're going to attach it to the bottom of our robot. So let's go. So there we go. Check that it doesn't move. We don't want moving parts here. Okay, perfect. So as you can see, you don't need the screwdriver for a lot of things, just for very precise stuff that your fingers can't do it. Otherwise, fingers are much more precise and good for this, because you won't overexert pressure on the components. Okay, next part. Let's marry the battery with Raspberry Pi. So now we have the battery pack and Raspberry Pi ready to go. The only thing that it remains is the connector, which we're going to connect right now. There you go. So we have our connector. And now what we're going to do is mount it on top of the robot. So as always, now we're going to unmount this again, just because it will be easier. There we go. So now we can move the robot side for a minute. So now what we're going to do is mount it, and now it just remains to find the right spot to place it and then screw them, okay? I found that these diagonal ones work fine, so try that ones. It could be, like in my case, that it doesn't adjust perfectly, so this is important. It doesn't matter that you don't screw the third one, because I don't have it. Just bear in mind that this could happen, okay? So with 3 points is more than enough. It's sturdy, so it will move. And now let's screw it back to the robot. And that's it. As you can see, I didn't screw the center screw just because it's unreachable with this configuration. So here we have it. So we have our camera, our Raspberry Pi, batteries, motors. So now we're going to screw the motors back. And now we're going to screw the connector. And that's it. So now we have our robot ready to go. We just have to plug our Raspberry Pi and plug our motors. Yeah, so now this is the part of coding and configuring all the systems to be able to move our robot and see the camera through ROS. So the first step is to download the Git. We created a MorpheusChair Git and we updated it with the newest scripts for this episode. So yeah, when you download it to your system, you'll get something like this. And basically what I've done is just open the Raspberry Pi script, and inside it go to Setup Ubuntu Mate MorpheusChair, and the first script that we are going to execute is this one, which is essentially what we're doing is installing basic elements that we need for Raspberry Pi. So in this case we are just updating the repos, and then we install Vim, of course, Git, of course, open SSH server, very important because we need it to connect, then Terminator, and then we set up some stuff for SSH. Basically what we're doing is enabling SSH. Why? Because by default the Ubuntu Mate for Raspberry Pi, it doesn't have SSH enabled, so we have to enable it. Otherwise, no matter what you do, you won't be able to SSH or connect in any way. Okay, and once that's done, then you just execute whoami to get the user and ifconfig to get your IP. You also can get the IP of your Raspberry Pi through many applications that you have for mobile phones or any other systems that just scan the IPs and MAC addresses of all the devices that are connected to your Wi-Fi, and you'll get something like the username, so in this case MorpheusChair, blah blah blah, and there you'll get the IP. So it's really important that you know the username of your system, Raspberry Pi, then the IP, and then the password. Yeah, all this has to be executed in your Raspberry Pi. So you'll have to connect it through HDMI, the keyboard, and execute this script. I won't show you how to do it just because we saw it in a previous video. Then when you execute this script, basically you're doing that, and also you're installing this XRDP. So this allows you to do remote desktop. So you will not only be able to SSH and see the terminal, but also the whole desktop. So you won't need never again to connect your Raspberry Pi to an external monitor. Okay, and we'll use Remina in our local computer. So this is the one that you have to install in the computer. So I would do it here, just there. I would just copy this and install it in my local system. I already have it, so no need for that. Once it's done, let's connect through SSH. So you'll have to power your robot. Remember, there's a switch in the battery pack. Just turn it on and wait a few seconds until you'll get eventually the IP. So let's do an SSH. MorpheusChair, then the IP, then you'll get prompted the password, and there you go. Easy peasy. So now we have access to our robot. Another way of doing this is through Remina, so remote desktop. So let's do it. Let's fire up Remina. Let's connect to MorpheusChair Raspberry Pi. If you don't have one, then you have to create a new one. Put the name, put remote desktop protocol, you put the IP, then the username and the password. It's exactly the same thing. Then you have to set up the colors. I would recommend to use True Color 24, for example. Otherwise, it could give problems. Once you have it, you have to save it and then connect. And that's it. After a few moments, you'll have the remote desktop. So you have everything you would see in the connecting your Raspberry Pi to an HDMI. So we have the Terminator that we just installed, and we have it here. So we can do anything that we could do in the other place. Catkin workspace, source, and MorpheusChair, blah blah blah. And there you go. And this way you can do anything you want. Okay, now that we have SSH enabled and installed, now it's time to install ROS. For that, you just have to execute the following scripts. If you go to Raspberry Pi scripts and ROS kinetic install, which basically installs ROS kinetic and generates this Catkin workspace in your Raspberry Pi. So if I go here and I do ROS version D, I have kinetic, and if I go to Catkin workspace, effectively I have this. So now we have to move our repository to here. So we have MorpheusChair. Fantastic. Once we do that, then we have to install all that is related to the camera. This is, you have to go to camera tests and camera setup. You have to install these two things through SSH, and be sure to enable this in this file. Let's have a look fast. and look for start X. There you go. So normally this is commented, so there's a hashtag, so you have to remove that hashtag, and also you have to uncomment this GPU 128 also, so that's enabled and works, the camera. Yep, fantastic. And then you have to reboot. Once you have this done, then you set up everything that it's related to ROS. Okay, this means installing all the packages that are needed for image publication in ROS, and then you have to go to Catkin Workspace, and here you have to download this Raspberry Pi cam node, which what it does is get the images from your camera and publish an image topic in ROS. That's it. Let's do a test. We just have to go to Catkin Workspace, Source. We launch this launch, that what it does is launch the camera. There you go, but it's not initialized. So what we're going to do is do an SSH. So SSH MorpheusChair. But we don't want to do this. What we want to do is do an, sorry about that. MorpheusChair, yeah, okay. So we want the X enabled so that we have the GUI that we have installed in a local computer pop up. Okay, great. So now that we have this, we just have to start the image publication. So we call this service, it starts capturing, and now we launch this. Another option would be to connect through Remina and launch this with a normal SSH without X, and that way we could see in Remina the GUI. But this, I think it's faster and more convenient. And there you go. So as you can see, the GUI popped up just because I have image view installed. But if you don't have it installed, then the option is Remina, because then you only have to install it in the Raspberry Pi. So it depends on what you want to do. Yeah? So let's continue. So in this last part, what we're going to do is move the robots. So we're going to start a launch file that what it will do is start the ROS topics, start the camera publication, and be able to see what the robot is seeing in real time through SSH. Cool, huh? So let's go. So the first thing is connect through SSH with the X enabled. So to do this part, the robot has to be unconnected to any cable, just because it's otherwise if you move it around it will have problems. And you have to connect not only the power to Raspberry Pi but also the power to the motors through the connection of the jack that we saw the other day. Let's have a look at the launch file that we're going to launch. So we have this package, neat package, that here we are going to post all the code that we're going to do throughout the episodes. And we have these 3 launches. Let's have a look at this one, Robot Bring Up Launch. This essentially what it does is launch the other 2 launches and also launch our camera module publisher, that essentially what it does is publish the camera images in ROS. That's what it does. And then we have Camera Show Launch, which what it does is open the GUI to see what the camera is seeing. And then we have also the motor driver start, which is the one that has more code. We are executing this move with command velocity.py. And if we go to scripts, we see that here we have a class which is called robot mover, which does the following. We start it and we start the listener. The listener is just a spin that stays there forever and ever. And when we initialize this class, it does various things. One, creates a subscriber to command vel. That's the topic where we will publish the commands to move the robot around. And then we start the motor driver, which is the one that we did in the previous video, just a little bit cleaner. And we define this function, which is called set speed, that will set the speed based on the linear, based on this value that you give here. It will increase the value of the speed. That's it. So then we wait for this Raspberry node start capture, that it's the one that we called to start. Once it's ready, then we do a request, which is an empty request, and this will start the camera. That's the manual service call that we did just a few minutes ago, but through Python code. Then once this is done, then we stay here forever. And the only function that it's called is the command vel callback. So when it gets a command vel topic publication, then it gets the linear value and the angular values, and then sets the speed based on the forward speed. I know we can do much more complex and fine-tune this so that it turns really well, but this is a very simple but practical way of doing it. Then we check, hey, is the turn speed positive, negative, or 0? If it's positive, then we want to turn to the right. If it's negative, then we want to turn to the left. Yeah? But we can turn it around. So we just have to put this here and this here, and that's it. Yeah? So it depends on the configuration and the way you cable, you plug the cables, depends on all that stuff. Okay. So if there's no turn speed, then let's see if we want to go forwards or we want to go backwards, or we want to stop. If it's positive, forwards. If it's negative, backwards. And if there's no linear, then we stop. That's it. And that's quite it, I think. So let's fire this baby up and see what happens. So now the only thing that we have to do is launch the bring up and see how this works. Okay, fantastic. So we have the camera. There we go. So now what we're going to do is open another one, SSH. So now we're going to launch here ROS run teleop twist keyboard and move the robot. So let's go. Whoa. Whoa. So as you can see, it's alive. It's alive! And let's go. We're back. So that's all for today. Please leave in the comments below any problems or any suggestions that you might have, especially the ROS related topics and any doubt that you have. And that's it. So thanks a lot. Please consider subscribing. Smash that like button if you like this video. In the next video, we're going to do two things if we have time. The first thing is build a better support for the camera, and the second thing is with the camera do line detection to be able to follow a line on the floor. Yeah? So until then, keep building, keep building, keep building, keep building, keep building.